I realized that next Monday we won't have any class. We won't have any class on the next Monday. So and the deadline for homework 1 is Monday. So please turn it Tuesday. Just drop your paper into the box outside of my office on Tuesday, anytime. Good afternoon.
Good afternoon.
Okay, let's get started. So some of you already know how to use MATLAB, so I think this is a really good time to kind of review and then gain more knowledge on MATLAB and be more comfortable in using the MATLAB. Okay? We're going to use MATLAB for the computer modeling for cardiovascular system in this class. And then you're going to use MATLAB again in the neural engineering and machine learning. But at your junior level, by the fluid, you're going to use MATLAB. And then in my class, biomechanics, you're going to use MATLAB in my biomechanics class. So anyway, so you end up using a lot of MATLAB a lot. So please just work hard on getting anything from this kind of tutorial. And first of all, there's so many resources on MATLAB, and you're welcome to find any resources out there. But I just want to give you some basics and fundamentals of MATLAB from now on until maybe 4 or 5 tutorials, using the 4 or 5 tutorial sessions. So the MATLAB, you can think about MATLAB as just like a super powerful graphing calculator. And in addition, it is a programming language. So you can just make a program for data analysis or making plots or even interfacing with external devices and so on. So this is pretty well designed, like programming languages. And we learned the MATLAB. And for example, whenever I make a plot for my publications of journal or my conference posters, in order for me to make a professional plot out of my work, I always use MATLAB. So when I make this, for example, when I make this kind of 8 different figures, I only use this couple of commands. So MATLAB is really powerful and flexible. So you can just set anything if you want to make something, then MATLAB gives you really freedom. Okay, so I hope you already installed the MATLAB already. So I just want you to take a look at what's the front page of the MATLAB. Once you run the MATLAB, you will see this is kind of front page here. So now you see, if you look at this one, you see, let me just use this kind of marker here. So I can use this marker. So this is a command window. So in the command window, we are going to type all the commands in the command window here. So you see those kind of cursor. And then another thing you may want to look at is this workspace. So in the workspace later, once you create any variable, you will see all the variable registered on the memory. So you can see all the variables you created in this workspace. And then another one is command history. So in the command history, you can just refer to command you already used. And this is pretty saving your time. And then another thing you may want to look at is this kind of directory here. So this is your working directory. Okay. So once you set the working directory in here, you will see all the file under that directory. Okay. This is all the file under that directory. And sometimes if you run the MATLAB try to, for example, if you try to load any file, then MATLAB tries to load file under your working directory. So sometimes you need to change the working directory so that the MATLAB know where your file should be there. So that's why working directory, just take a look at the working directory. And then the top is just the top menu button. So you can change anything using this top menu button. Then let me just start our first MATLAB sessions using this example, okay, exercises. So now somebody launch a ball, okay, and then when somebody launch a ball, it has certain initial velocity, and then this is angle, a 45 launching angle, and then this is gravitational acceleration. Then after somebody launch a ball, we want to track down what is the position of each kind of ball as a function of time. So that's why this xy position derived from the physics law. So now x and y of the locations of each ball can be determined by this equation. The initial velocity times cosine theta and time t, and y is has some like a gravitational acceleration because gravity kind of pull down. So using these simple equations, we are going to get some x and y. So go to your command window and then try to type. Okay, try to type all these kind of things. Right now, I just want you to compute. I just want you to assign what is the initial velocity. So you just create a the initial velocity, and then now after that you assign a theta variable. So now theta is 45 degrees, so pi over 4, and then your g 9.81, and then I want to know what is my x and y of the ball when time is equal to 1. So that's why I specifically assign 1 into time t. After that, you just write down this equation. Okay? So you call this cosine function, you call this I also typed myself as well, so I will just pull up. So I'm sorry about this one, but let me just show you here. So as you notice that in my MATLAB environment here, I had one more window, so which is editor window here. So you can type anything on your command window. For example, my initial velocity is 5, and like that. Or if you want, but the problem is this is just command window. So which means if you just type many things, your previous one just stayed just located at the top. So if you want to make this one is like editor, you can just go to new and then click new and then script. Click the script. So if you go to click and then new and script, then you see those kind of editor. Okay? This is my editor. So in editor, you can write down everything in editor. So that means you do not run yet. Okay? You do not run yet. I want to type everything first and then run everything at once. That's the job for editor. So I just use editor. Okay? In that case, it's very easy to edit later. And then G is 9.81. And then another thing, another benefit of the using editor is I can put the command. So if you use this percentage symbol, that means anything you type followed by the percentage, it just comment. So it's not recognize any command. So I can type any like explanation. This is, for example, this is a meter per second, for example. This is a meter per second. And then I just write down this is radian. I just want to comment what is the unit of my thing. Okay, this is meter per second, and t is 1. I want to write down this is like a second, and then my x is equal to v naught time cosine theta, and time multiplied by time. And then y is equal to v naught and sine theta multiplied by t minus 1/2 times g and t square. So when you use the t square, you can type the t times t, but t square also can be typed like bracket and 2. That's the square thing. Okay, that's the square. So once you type everything on this like editor, then we can easily run. For example, you can just copy everything. You just copy here and Control C, and then you can Control C and then click command window and Control V. You can just copy paste onto command window and run. So I have a typo here, so data, this one should be data. So let me just redo. I just copy and paste, enter. So I ran everything. So if you look at the on the right side in the workspace here, so look at the workspace. Now in your workspace, you see all the results and all the variables you have created. So you created G, T, data, and V naught, and these are your answer, X and Y. These are values. So the workspace shows all the value of your variable on the memory. Okay? Then not by looking at the workspace. If you want to check the value of X and Y, it's easy. In the command window, you can type X and enter. So if you just type an X and enter, this command window will display the value of X. And Y, you can just see G. You can just check very quickly if you want. So this is the way how we use the MATLAB. So from now on, let's use editor at the same time with the command window. So we are going to use multiple lines. So we are going to write down all the command all together and then run everything at once. So we have to use editor. Okay? You can save your comments. Right now, this is untitled. So if you want to save it, you can go to there and save your editor comment lines. So later, if you want to load it, you can open it. Okay. Now I told you that the MATLAB is programming language. Okay. So in the programming language, we should know how to declare the variable, how to assign the variable. Okay. So let me talk about. Let me show you some of the way we define the variable. So now, when you create any variable, okay, you simply value to a name. So did you remember when you learned the C? At the time, in order to declare the variable, we have to specify the format of the variable, either whether it is integer, float number, or string. You have to think about the float first and specify the format of the variable. But in the MATLAB, we don't need to do that. You can just assign any number or any string into any variable name. Okay? So it's pretty simple and intuitive. But importantly, when you create the variable name, your first character must be a letter, not number. So you cannot make one var or something like that. This one cannot work. So the first character needs to be a letter. And then your variable is case sensitive. So that means if you want to create a variable, so your variable name is var and var. These two variables are two different variables. Okay? So case sensitive. And also, when you create the variable, maybe do not use predefined words, something like a pi. Pi is actually predefined words in the MATLAB. So pi always refers to like this pi. So do not use those kind of built-in variable such as pi ends or infinity or none, something like that. Okay? Or ij. Sometimes I use ij, but sometimes MATLAB recognizes I as imaginary, like complex number. So use your unique kind of variable. And then I can explain this one later. And then speaking of the data type, you can make a variable like scalar variable. So this is a single value. So in a case, this is scalar variable. And then you can create like an array or vector. We call this as a vector or array. This is a one-dimensional array, right? So you can input your variable like one-dimensional array. This is two-dimensional array. So we call this as a matrix, right? Matrix. This is a one-dimensional matrix, but we just say this is simply vector. Vector or matrix is scalar. And then when you make a variable, you can even use some computations on the right side. Then the answer will be assigned to a variable name. So you can just put the equations in order to create a new variable. And then right now, I'm not sure whether you noticed or not, when you use the MATLAB, I try to use here, the semicolon at the end, right? So you don't need to, it's not necessarily to use a semicolon at the end of your command, but just to see what's the difference between using semicolon or not. For example, when I run only this one line, fifth line, let me just show you. So when I just type this one, okay, if I don't include semicolon, if I run, the answer will be displayed on your command window without the semicolon. But if you use a semicolon, then enter, it didn't show out the result on command window. Okay? So semicolon kind of suppress the outputs in the command window. That's the semicolon role. And then can can you quickly type? Can you quickly run? Try to get the answer for 1 divided by 0. Try in the MATLAB. What would be what looks like? What the answer looks like? 1 divided by 0. Infinity. How about the 0 divided by 0? NaN. So NaN infinity. So this exponentiation is this the bracket, okay, and then this one. Sometimes we just make mistake because the MATLAB is still programming language, so it's not human interpretation thing. So you have to insert the multiplication operand, okay? And if you want to clear your command window, type the CLC, okay? So for example here, if I want to clear command window, I just type CLC. So you can just clear your command window, CLC. And another good thing about the MATLAB provides lots of built-in functions, such as SQRT, right? SQRT, and then the log with the base of 10. This log, okay, this is a natural log, okay. It's just a log 2 in the MATLAB. It's the same as natural log, okay. So if you want to use a log with the base 10, you have to put the 10, log 10. And then this cosine, atangent, sine. Please remember, in the MATLAB, whenever you use cosine sign, the parameter must be a radian. If you just put the degrees, MATLAB understand it as a radian. So don't, please remember, okay? And then we have another function, kind of a round function. And I think this is like, floor is kind of truncate instead of the rounding. And then this is another function related to dealing with the imaginary number. So don't worry about this one right now. And another thing you have to remember is sometimes if you don't know how to, for example, I don't know how to use function, for example, absolute function. So in that case, just type help and maybe a tangent. So in that case, this one just to show you the syntax of those kind of functions. So if you know some function you need to use, but if you don't know how to properly use the function, then you can just type help and a tangent, then it just gives you all the information. But if you want to really, if you need a more detailed information, then use a documentation, doc A10, okay? So this one gives you really more detailed information about some function that you type here. If you just put the doc, it's just showing up this documentation. So you can see all the very detailed information about even the example here. You can see a lot of example, and you can see all the syntax. So doc or help is pretty much frequently used. Okay? Frequently used. Okay, as your first exercises, as your first exercises, try to hold on. Let me show you. Let me use this. As your first exercises, do this one. Okay? Do this. verify that left side is the same as on the right side when x is pi over 3. So try to get the answer by plugging x value into the left side, exponential of I times x, and on the right side, cosine x plus I times sine x. So try to get the answer and then try to verify the left side is the same as on the right side on your program. Okay? So while you're doing it, I do myself on my computer on the MATLAB here. Okay? So first of all, I need to just input my x. So this is pi over 3. So I just type the pi over 3. And then my left side of value is exponential something. So I just call it variable 1. So and then this is exponential I times x. Okay? I just follow. So that's my left side variable. And my right side variable, I just type cosine x plus I times sine x. And but before I run this code, on my workspace, I have some variable that I have created from my previous example. So I want to clear them out. So if you want to clear them out, you can go to the workspace and click on the right button. You can just delete from here. But rather than do that, in the command window, you can just type clear. What do you want to clear out? Do you want to clear all variable or only one variable? Clear all. Let's clear all. Okay. If you type clear all, then all the variable on workspace will be removed. Okay. So clear all. After that, let's clear my command window and then just copy and paste on my command window and run. So when I run, on my right side, I check my value. So my variable 1, variable 2 has the same variable name, variable imaginary as an imaginary number. So I now know that I can verify my left side is same is equal to. Okay. Or if I try to subtract my var1 and var2, then I see my answer is a 0. So that's the way I know that the left side is the same as on the right side. And then right now I just to show you how to run multiple lines at once. So you can just copy and paste and run it. But there's another way to run your line. So if you want to select everything, okay? If you want to select everything and click on the right button. If you select multiple line that you want to run and click the right button, there is an evaluate selection in command window, F9. So you just select whatever the line you want to execute and F9 or click on the right button, this one, then that's the same. So that's the same as you can copy and paste onto command window and run it. So, for example, I want to run only one line. So in a case, you can just select one line and F9. That means I just only execute one line. So F9 is very useful key in the MATLAB. Okay, F9. That's this one, F9. Another way to run your code is that right now in my editor, this is untitled 2. Okay? So I want to save it. So for example, I want to save. So I want to save under my, for example, document. So I can save this is like exercise 1. I just saved this one exercise 1, but don't insert any blank. When you save your edit MATLAB file, don't insert any blank in your file name. Okay, everything should be connected without blank. So exercise 1 and enter, which means I saved my file as an exercise 1.m. So extension is automatically .m. After that, in the command window, you can just type your file name, exercise. Let me clear all my memory first. Okay, let me clear all my memory. And then exercise 1. I just type my file name and enter. That's the same as you run everything. Okay. Or I clear everything right now. Or you can quickly go to this run button. Okay. Run button. So I just click the run button. Then you can just exit or everything in this editor. Okay. Run button. Okay, so this is second exercises. So can you try to get the value of r? So the r is the radius of the circle. So the formula is given right now, and then other parameter value. So I already gave the answer here, but try to confirm that your answer is the same as here. So A, B, C are given like 5, 6, 7. So using those kind of information, using this formula, try to get the R. Using your editor, okay? Using your editor. Type all the command in the new editor, okay? So you can go to the new here. So click new editor. So type and then start from here. Okay? Start from there. So I also try myself here. So now A is 5, right? And then B is 6. C is 7. In my editor, I just use one line, but you can let me see whether this one works. Yes, it works. So I can even make multiple statements in one line. Okay. And after that, I just type all the formula here. So right now, numerator. So maybe I can say my variable, the variable numerator is equal to A times B times C, and variable for denominator is so long. Okay, so I cannot do A, B, C times A minus B plus C times B minus C plus A, okay? And then C minus A plus B, okay? But I need to do the square root, so I just call SQRT, everything in my parentheses here. So SQRT and everything is in there, and this one. Okay, after that my R is equal to my numerator divided by okay, so now I think I typed everything, so I just try start to run F type of new. So my R 3.572. Okay, yeah. So I typed correctly. My R is 3.577. Or if you want to display out onto the command window, you can type like, so for example, like display my R. So in that case, you can display your output onto the command window. So if I run it, now my answer is, oh, I didn't save it yet. So using the MATLAB, just very similar to use like powerful like a calculator, right? We just use the MATLAB right now as just like a calculator, but we can just type everything in kind of using the keyboard instead of button. So that's the only the difference. Okay, I hope you get all the correct answer. Then let me move it on. I already explained everything here. Now let's try to learn how to create a vector. Okay? So what I mean by the vector is the multiple values. Okay, multiple values. So in here, you can make a raw vector. Raw vector means this is horizontal vector. So my raw vector has 1, 2, 3, 4 elements. When you create the vector, you can put a comma. I think using comma is a good way to do it. So let's use the comma. Okay? But even without using comma, the MATLAB understand these are four elements. Okay. Then after you create the vector, if you check the workspace, now because this is not scalar vector, that's why the size, you can see this is 1 by 4. This is a row is 1 and column is 4. That's why this is a 1 by 4 vector or 1 by 4 matrix. This is a raw vector, and then likewise you can make column vector. So column vector is horizontal vector, vertical vector. So in order to make a horizontal vector, now you put the semicolon between each element here. So semicolon separate value between those kind of elements. In a case, your vector will be created in a vertical way, 3, 2, 7, 4. So if you check the workspace, your column is 4 by 1. This is 4 by 1 matrix. So 4 row and column, 1 column. So now we know how to use create a row and column vectors. And now, after you create either raw vector or column vector, sometimes you want to check how many elements you have in the vector. This is 4 elements. So this is length 4 and size 1 and 4. So in a case, we can simply call the functions of like size or length. Okay. So if you just use the size function, it will give you the number of row, number of column. If you just use the simple length function, it just gives you how many elements you have in that vector, okay? You have 4 elements, that's why this is 4 elements, but size-wise are different. These are 2 different sizes. And then also, you can transpose your vector. Once you create a row vector, this is a row vector, right? Then if you want to transpose it, you can transpose row vector to column vector. So you can use transpose it, or simply you can put this apostrophe. So let me show you. So for example, I create a row vector 1, 2, 3, 4, 5. Right? So this is my row vector. If you just use a apostrophe, it becomes vertical, a column vector. So B is equal to A apostrophe. So my B is column vector. So if you use a B apostrophe, it becomes a row vector. So you can transpose from row to column, from column to row by using this apostrophe. Okay? And then another things to learn how to create a vector. Sometimes if you want to create vector in a certain pattern, so for example here, I want to create the time vector from 0 to 1, but I want with an increments of 0.2. So this is pretty routine kind of pattern. In that case, rather than type everything, you can there are some shortcuts. Means I can create the time t. This is a starting, and this end is ending, and this is colon, and this is increments. So this is starts and colon, increments, and colon end. In that case, you can just make the vectors quickly. Okay? So using this kind of concepts, then let's try to go back to our original example here. This is our original example. In this original example, we let's try to time t as a vector. Can you just change your t to like a vector and then run your program and see what the result look like? So in here, I will show you my slide, and then at the same time. So in my case, I made already. So you already kind of typed. I hope you didn't delete your editor window before. Okay. So this is my editor window. Did you delete everything? Well, okay. So this is only 5 or 6 lines, so you can quickly type. Okay, here, okay, my time, I want to change my time, so instead of using scalar, I want to use time as a vector. So in here, I want to make my vector, so start from time 0 and increment is 0.2 and 1. Okay. So now my t is a vector. Then my question is, after you make your input variable as a vector, then you multiply this t to this equation, right? The next one. You multiply this t to this one. Then do you think your result x will be also a vector then? Because now you're multiplying you're multiplying constant with the vector, which means you should anticipate that your x should be vector as well. So that means your x is all the x's for all the time informations in here. So that's why we can get the answers at all once. So try to run. So I changed my t. So let me clear all my memory and then clean up my command window. Then I will try to run up to the 5th line, not excluding 6th line. I include the 6th line. So when I run, I just copy and paste it, or I just select my 5th line and F9. When I run, surprisingly, my x also shows a vector. So I think this is a really good, because I want to know what's the x change, the position of my board. So my time has 5 elements. So my time has 1, 2, 3, 4, 6 elements from 0 to 1 second. So accordingly, my x position shows that. Okay? That's why I think this is really convenient for us, because for all the possible time t, I want to get all the possible x. So that's why x becomes vector automatically. Then let's try to run the last command here. When I run it, I got error here. I got error. The reason that we get error is because look at this here, t square. So t square is what? T square is multiplies 2 times. So did you remember? Let's say we have a matrix. Let's say 2 and 3. So this is a 1 by 2 matrix. Can you multiply 1 by 2 matrix by another 1 by 2 matrix? Can you multiply that? This is a 1 by 2 and 1 by 2. Can we multiply 1 by 2 by 1 by 2? No, we can't. So in order to multiply 2 matrices, the column number for your the first matrix should be the same as the row number of your second matrix. Did you remember? So in order to multiply, you have to make the second matrix is 2 by 1, like that. So that means this is 1 by 2, and second matrix should be 2 by 1. So this one should be matching. This 2 and 2 should be the same. In that case, your answer is 1 by 1. So this is matrix multiplication. So now, when you use this t square, now your t is a vector, right? T is 1 by 6 vector. T is 1 by 6 matrix. But if you try to multiply 1 by 6 to 1 by 6, it causes error. It causes error. Okay. So that's why one way to get away with this error is you have to do this is element-wise multiplications. Element-wise multiplication is something like 1, 2, 3 times 1, 2, 3. Then you can multiply 1 with 1. You can multiply 2, 2. You can multiply 3, 3. So that's the element-wise multiplication. This is called element-wise multiplications. So in order to do element-wise multiplications, you have to put the comma in front of any operand, which is parrot in here. Okay? So I put this 1 point, which means I want to compute t square in element-wise multiplication, not matrix multiplication. Am I clear to you? Did you follow me? I think this is very important thing in the MATLAB. Otherwise, you have a lot of error later. Okay? So if you change it, then if you run it, then you can run without any problem. So in that case, you can get all the y value depending on each different like a time information. So this is a vector, t is a vector, t is vector, and then you do the element-wise multiplications for t squared. So each t value will be, each element will be squared, okay, and becomes vector. Okay, so this is the kind of vector. So let me just put the parentheses here. So let me just show you here results. See, so this is a t squared, so which means 0 times 0. This is 0.2 times 0.2. This is 0.4 times 0.4, and so on. This is because our t has only this time, 0, 0.2, 0.4, 0.6, 0.81. So if you do the element wise, t times t. So this is element. This is element wise multiplication like that, which means the first element is multiplied with first elements of the second matrix. The second element will be multiplied by second element of second matrix, and so on. So I already explained this my slide here. So like this one, yeah. So element wise is this is a matrix multiplication is not possible. That's why we use this. Put the dot in front of the operator. Okay. Any questions so far? Any questions? Okay, now we understand, we now learn how to create a row vector or column vector. What if we want to create a two-dimensional vector at once? So in here, in this example, if you use like a semicolon actually tells that everything followed by semicolon is the next line. So that's why if you use a semicolon, then the MATLAB creates a vector as 1, 2, and 3, 4. Okay? This is semicolon. And so look at this one. I think this one gives you better ideas about how we create one-dimensional or two-dimensional array. So if you just define your array 1, 2, it becomes a raw vector. If you use a semicolon like that, this is 5, 6, that's why it becomes vertical vector. Now, you already defined A and B, right? A, B is 1, 2, and 3, 4. That's why if you use like A, semicolon B, the A, 1, 2, and 3, 4 is kind of stacked vertically. Okay? So this is a vertical stack. And another interesting thing is this one. So if you, because I know that my D is already a 2 by 2 matrix. So this is a 2 by 2 matrix. And then my C is a 2 by 1 matrix. So that's why if you just type like D and C, so D and C like that, which means 2 by 2 and 2 by 1. So this one is stacked horizontally like that. Okay. So these are this is a D, and this is C. So you can stack horizontally, and let's not worry about that. I think this is too complex. Okay, this is your exercise. Can you create R vector that has 3 by this matrix? So you see those kind of specific pattern here. So it starts from 0 and ends to NT. Increment is 2. In here, it starts from 0, ends 10. Increment is 1. The third row starts 0 and ends -2. Increment is -2. So you know the pattern. So try to make R vector so that R vector has 3 row, and whatever number of these columns. How can you do that? So maybe you can just break down your work. So think about how to make your first row. Okay? So maybe for example row 1. How can you do that? Starting is 0, right? And your increment is 2 and end is 20. And then row 2, 0, increment is 1, 10, row 3, 0, -2, -20. So after you create each row, after that you stack them. You stack vertically. So R is equal to row 1, and this semicolon is stack. Oh, do I have to some semicolon or colon? Is it colon, right? Let me show you. Colon, not semicolon, colon, okay? Please correct my mistake if I made mistake. You're very kind. So let me correct my mistake. So this one is not semicolon, colon, okay? Colon and colon. And after that, this is semicolon, okay? This is semicolon. Row 1 and row 2, comma, and row 3. How about that? I think that this one should work. So let me type here clear or PLC and row 1. Yes, I got it, right? So as you see that here, my R is 3 by something. So as I told you that if you quickly check the size of your matrix, size R, 3 by 11. 3 by 11, how about the length? length r. So if you type the length r, this one just gives you number of column, not number of row. Okay? However, if you type like a length row 1, it gives the same number 1, 11, right? So size row 1 is 1 by 11, so size r is 3 by 11. Okay? So now we know that maybe you can simply look at the workspace. In the workspace, my r is 3 by 11. Okay? So now let me show you this kind of multiplications between the matrix r times. Okay? If I just multiply r times row 1, it causes error. Why? 3 by 11 times 1 by 11 won't work. So, for example, if I just type row r times row 1 apostrophe. What is apostrophe? Like transpose, right? So this is like 3 by 11 times 11 by 1. Okay? So my answer is 3 by 1. Because if you multiply 3 by 11 times 11 by 1 matrix, then your final answer is 3 by 1. Okay? So that's why I can do proper like a matrix computations as long as you know that those kind of matrix size. Everything is clear, okay? Okay, then let me skip this part here, and then let's go to. Oh, before I moving on, let me just show you one more thing here. So now we have 3 by 11 matrix. Okay, this is 3 by 11. R is 3 by 11. Okay. So r times r comma, this one gives you 3 by 11, so 3 by 3 matrix result, right? Then r times comma r comma multiply r. What do you expect this one gives you here? So this is element wise multiplication. This is element wise, which means if you just look at this r compared to this r, let me just compare the r element wise r. This is r. So if you look at this one, element wise multiplication is that this one times this one, this one times this one. So 2 times 2 is 4, 4 times 4 is 16, minus 4 times minus 4 is 16. So element wise, it's just multiplication between the same located elements. Okay? So that's this element wise multiplication thing. Okay, so I hope this one I made myself understood to you clearly. Okay, then moving on. And additional initialization is sometimes when we create a vector, sometimes we want to create a vector and fill the vector with one, fill the or one into the vector. So you can just remember this is simple like a built-in function ones. So you can create or ones, one initialized with 1. This is a 1 by 10 matrix. So here, if I just type A is equal to 1 by 5, then your A is 1 by 5 matrix with all ones. How about zeros? Zeros 1 by 5 or 1 by 5 zeros. Okay. But please don't. Please remember, if you just type only single parameter, by default this one will give you 5 by 5, not only single vector or single line. Okay. And how about the rand function? Rand function 1 by 5. It gives you 1 by 5 filled with a random number. Okay? So sometimes it's very, we can quickly make any vector using ones and zeros and any random number. And then another automatic initialization function is a linspace. I think this is a really frequently used in the MATLAB. So in the linspace, we want to start from 0 and end 10, and this is 5 is how many value you want to space out. Okay? So right now, if you want to use a linspace 0, 10, and 5, let's try. So linspace 0 and 10 and 5. Look at that. This one creates exactly 5 elements evenly spaced between 0 and 10. So I want to create 5 elements, but those 5 elements starts exactly 0 and end exactly 10, but everything is evenly spaced out. So that means if I want to make a linspace 0 to 10, maybe 6 elements, then this one automatically calculate increments and then create those kind of elements. So how about the 7? So I can just space out evenly as long as I need the 7 elements and so on. Okay? So that means when we make a row 1 at the time, we just use 10, 0, and 2, and 20, right? Something like that. I can create row 1 using the linspace, and I want to start from 0 and end 20, and my or element is 11. That's the same. Okay? That's the same. Okay, these are exercises. So using the MATLAB, try to create X variable. This is vertical array, and then compute the value for Y. Okay, and after that, create A matrix using this 2 by 2 A matrix, and try to multiply Y and A, and this is inverse. So when you use the inverse matrix, use the inverse A. Okay? So this is a function of the matrix inverse A, and this T, this is a transpose, right? This is transpose. You can transpose your matrix. So try to get the answer. Okay? Try to get the answer for B, C, in E, and Y. So create the file assigned to them given a value. So Y value and B and C and E. equal to 2 semicolon 1. So I want to make this one as the vertical order. Okay? And the y is equal to so 2 by 1, 1 by 2, so x transpose, so x comma, so x apostrophe is transpose it, and then I want to multiply 17, and then also multiply 1001, so you can create 1001 using a variable, but maybe you can just type here 1 comma 0 and semicolon, next line 0 comma 1, right? You can do that. And a likewise 7 comma and 2 comma 1, okay? And b is now if you run the y, you have to think about what would be the size for the y. Okay? So we transpose x. This is a 2 by 1 by 2, so this is 2 by 1, and times 2 by 2, so it becomes 2 by 2. So y, the results, that should be 2 by 2. Okay? So that means I can multiply y and a, y with a, right? So 2 by 2 by times 2 by 2, so that's what it works. So I just make sure that this is a 2 by 2. And c is equal to x transpose it. So x transpose it is x comma. This becomes 2 by 1 times 2 by 1, and then inverse a. So inverse a is a 2 by 1 by 2 by 2, and then b transpose. And E is equal to like that. Okay. I just type as it is, and let me just clear all my memory and CLC, and then try to run. So without any error, we have this size. I want to show the size. So I want to see the size. A is 2 by 2, B is 1 by 2. So whenever we use matrix, just look at the size. Okay, size. If the size doesn't match, sometimes you cannot do like multiplications of the matrix. And then one thing you have to understand too is, for example, A, CLC. So now A is 3721. Okay, we define the 2 by 2. So let's say A, and if you want to access the 3, if you want to access 3, how can we access the first elements A? And you have to think about what is the row number for 3. That's the first row, right? First row and first column. So A parentheses 1 and 1 should be 3. So again, so if you want to reference for example 7, that should be A 1 and 2. That's the 7. Yes. So the difference between MATLAB and LabVIEW, the LabVIEw, the index number starts from 0. But in MATLAB, index number starts from 1. Okay, my another question is, if you want to access the whole first column, I want to access whole first column A, and then I need to access whole first column. That's why I don't care about my row. That's why I put the colon. And my first one is my first column. So if you just type A colon comma 1, you can reference the whole first column. Okay, so if you want to reference the first row, A, first row, and everything. 37. Okay. And then another thing, I told you that in the MATLAB, we can easily make a string variable as well, right? So this is just string matrix. You can even make a logical variable. For example, 5 is greater than 7. I think if you run this one, A should be false, right? So now A becomes a logical variable. The result of this one is like a 0. So in the MATLAB, 0 as a logical variable is false, 1 is true. So A is, for example, I want to test 5 is greater than 2, then this is 1. 1 is true. So how about this one? 5 is greater than 3, 4, okay? So you know that this is true, plus 5. So if you run this one, what would you see?
6.
Because if this comparison will result in a logical number 1 and plus 5 is 6. So sometimes we combine the logical variable into like a standard, like a numerical formula if you need as needed. So this is the first lab assignment from this late afternoon lab. If you go to the blackboards, you can. I posted the MATLAB tutorial chapter books. So you can look at the chapter 1, chapter 2 from the blackboard. I just make a PDF and post it MATLAB tutorial chapters. So please read chapter 1, chapter 2, and then at the end of each chapter, you will see those kind of exercises. Okay? So from chapter 1, I wanted to complete exercise 1 through 4, and from chapter 2, I wanted to complete from 2 to 5 all the exercises. So after you do this kind of exercise, if you read those kind of chapters, you can just do pretty quickly. So I think these are all those kind of this is sample like a tutorial. Okay. And after that, screenshot your work, copy and paste the screenshot into Word documentation and submit to the Blackboard for this one. By next Friday, by class time, by noon. Okay? So next Friday, we are keep moving on to the MATLAB tutorial sessions. So please complete these two exercises by next Friday. So I just printed out to remind you. Okay?